Okay, just couple of quick ones on this one. Right, equation in slope-intercept form for the line shown. Right, slope-intercept form. Right, it looks like it has a y-intercept of 3. So it's going to be y equals something x plus 3. The number next to the x is going to be the slope. So let's have a look. If I just actually count from this point, from the y-intercept over to this x-intercept here, actually, it looks like it's gone down 3 and over 6. So it's gone down 3 over 6, and it is a negative slope. It's going downhill from left to right. So trying to recognise which is negative and which is positive. That's going to be negative 1/2. So there you go. That is the answer. Yes, remember, there's a positive slope, there's a negative slope. Think about going uphill from left to right or going downhill from left to right. Now then, quick and easy, but sometimes, once you realize what it is, it's not too bad. The zero of a linear function. The zero is what value of x makes the function into 0. Okay, in other words, I need to put 0 where the f of x is. Okay, what makes this equation 0? What value of x makes the equation 0? Okay, so in other words, I've just basically done that. That is 0, okay? So, maybe you can look at it. Can you see it's x equals 5? Okay, if you need to, add a 15 to both sides. So I added a 15 to both sides. Okay, remember, just add 15. That's gone. Divide by 3, x equals 5. So that is the 0. You'll see lots of terms like it's also the x-intercept, but don't forget, if you write it as x-intercept, you write it like 5, 0. It's a solution, it's a 0, it's an x-intercept, okay? So that's the 0 of a linear function. You're going to see zeros of polynomial functions. It's still what's the value of x that makes everything equal to 0, okay? Right, okay, what's next? Solving equations. Hopefully this is basic stuff, guys. I mean, it's just distributive law here. So let's run through this one. 29. Distributive law. That and that. So that's 6x plus 3 equals. Now don't combine those two, okay? This is 5. This is the distributive law here. It's not 5 take away 5. Order means multiply first. It's a negative 5 times a 2x, which is negative 10x. It's a negative times a negative 3, which is 15. Okay, that's what that is. Okay, again, forget about this 5 here for now. You're doing a distributive law with a negative 5. Okay, 6x plus 3 I'll leave alone. Combining stuff on the right, 5 and 15 is 20. That's still negative 10x. Is that right? Okay, I'm going to add 10x to both sides, which will give me 16x on the left. I'm going to take away 3 from both sides. So what's that? Take away 3 from the 20, that's 17. Looks like x is just 17 over 16. Not a nice number. Let me double check. 20, take away 3, yep, get 17, add 10, yep, there you go. Okay, right, question 30. Oh dear, it's fractions. Okay, now you don't have to find a common denominator. If you're adding and subtracting fractions, sure, you've got to find a common denominator. But if you're solving, okay, you can get rid of the denominators by finding the lowest common denominator. So you look at this, quite a bit here. We have 2, 5, 8 and 10. The lowest common denominator for that is actually 40. You could use 80 if you think 8 times 10. 80 will work. But what I'm going to do now is I'm going to clear the denominators by multiplying everything by the lowest common denominator, which is 40. Okay? So I'm going to, if I just put a 40 next to everything, if I squeeze it all in, okay? I'm going to multiply everything by 40. Now think of the 40 as a 40 over 1, okay? Because look, if I do it to the first one, 40 over 1, I'm going to multiply it by that half x, the very first term, okay? Can you see 40 divided by 2, just multiply numerator, multiply denominator, that'll give me 20x. There you go, that's the first term done. Let's have a look at this second one. The second one is 40, so you can write it as 40 over 1, and it's multiplied by a fifth x, so 1/5 x. Okay. Oh, 1/5, not x, just 1/5. Okay, let's just erase that. There you go. Okay, well, that'll give me 8, won't it? 40 divided by 5, if you think multiply numerator, multiply denominator, so that's plus 8. Keep on going. Okay, 40. What is that? Times 1/8 x. Again, I'll write the 40 is 40 over 1. So that's 40 on the top, 8 on the bottom. 40 divided by 8 is 5. And finally, you can see here, 40 times 1 over 10 is just 40 divided by 10 is 4. So again, I'm going to rearrange everything. I'm going to stick the x's on the left hand side. I'm going to take away this 5x from both sides. So that'll give me 15x here. I'm going to take away this 8 from both sides. Okay, so take away 8 from here. That will give me, what will that give me? Negative 4. So divide by both sides by 15. Okay, I'm going to get negative 4 over 15 as my answer. Okay, there you go. So again, solving equations. A lot of people don't like the fraction ones. Okay, last little piece. Inequalities. Okay, solving interval notation as well. Solve for interval notation. Okay, right. Inequalities. I'm just going to add a 9 to both sides. Y is less than 10. There you go. I just said the answer. That's it, folks. That's it. Right. So I don't know. I'll say this. I'll just make this 10 here. Now, if it, you see this, if it has an equal sign, you use brackets. Okay, that way or that way. If it doesn't, you just use parentheses. So this doesn't have an equal sign. I'm going to use a parenthesis, and I'm going to point this way because that's the way this Allen rope is telling me. Okay, so there you go. There's the diagram. It is numbers less than 10 that work. Now, interval notation means this. Where's it coming from? On the left, it's coming from negative infinity. Where's it going to? It's going as far as 10. And that's got the parenthesis. And that's it. That is the interval notation for 33. Okay. For 34. Now I'm going to do this all together. Look at this. Okay, if I want to isolate this x, right now it's telling me that 4x plus 4 lies in between negative 16 and 0. Okay, so I know it's kind of, the answer is going to be somewhere in between two numbers. Okay, so right now the whole of the 4x plus 4 lies in between visually negative 16 and 0. But I just want x by itself. So I'm going to take away 4. But you take away 4 from everywhere. Look, a lot more places to take away 4 from. It's not just either side of an equal sign. So I'm going to have negative 20 over here on the left. Keep that. Keep the 4x. I got rid of the plus 4. And what's that? Negative 4 over here. Okay. So now I'm saying, right, 4x lies in between negative 20 and negative 4. Let's divide by 4. Divide everything by 4. Finally, we have negative 5. X there, less than x, less than equal to negative 1. This is now telling me x lies in between negative 5 and negative 1. So if I do this, let's call this negative 1, negative 2, negative 3, negative 4, call this negative 5. Then, again, no equal sign here, so I use a parenthesis. Equal sign here, so I use a bracket. So there we go. What I'm saying is that the numbers I can use, what this question would apply to, is only between negative 5 and negative 1. And clearly, hopefully, the interval notation is pretty much as you've drawn on the graph. There you go. Okay?